things. And with a bit of luck, we'll have finished spherical coordinates, and we'll see whether we get time to start the next and final section for your test. So let's look at just one specific job in the spherical coordinate system. How do expressions in x, y, and z affect the range of values of rho, theta, and phi? Right. If you're told that the triple integral is over a region E and they describe it in terms of a sphere like that, if that's the only restriction, all that will do is affect the rho value. Great. Now, theta and phi will stay put. Theta for a sphere is 0 to 2 pi, and phi is 0 to pi. So as long as there's no other information given, right, no other constraints or restrictions, and the only thing you're told is that it's a sphere, well, they tell you that, they tell you it's a sphere of radius 4 or a ball of radius 4, then this is your restriction. If they give you this, isn't this basically a big sphere with a little sphere inside it? In this case, won't the only difference be that rho will be restricted between 2 and 5, but these guys and these guys will stay the same? Are we comfortable about what a sphere can do? Just a sphere on its own, nothing else. Okay. How about a restriction like z equals the square root of x squared plus y squared? Which, by the way, is a cone. Now, we did this guy yesterday. Essentially, don't you replace, oh, where's my list? Okay, I have my little list. Didn't you replace the x with this fella? No, that's the wrong list. So many papers here. Basically, you replace the x, y, and z by their spherical coordinates. There we go. That's the one I'm looking for. The y by that and the z by that. And didn't we solve? Can anybody, I know it's putting you on the spot, but can you remember what the restriction ended up being? Because it only affected phi.
Was it 0 is less than phi is less than pi over 2?
Oh, close. Okay, let's do it. Because if you can't remember it, you want to be able to derive it. Okay, z, which is rho cosine phi, is going to equal the square root of this guy squared plus this guy squared. Is this beginning to ring some bells? Okay, this guy plus this guy. Can't you pull out a rho squared sine squared phi as a common factor? And that leaves behind cos squared theta plus sine squared theta. But isn't that 1? And so it now looks like this fella. Are we good? Right. This becomes rho sine phi. We'll make the assumption that rho is not 0, because if it is, the sphere disappears to a point in space and we don't have spherical at all. And because I can do that, I can get to here. Okay, what does that do? What do I do next?
Divide by cosine.
And if you divide by cosine, you get that. And in the restriction of the world in spherical coordinates, there's only one value of phi that gives you a tan of 1, isn't there? And it wasn't pi upon 2, although you were really close.
Pi over 4.
Pi over 4. So if you are given a restriction that is caused by a cone rather than a sphere, do you see that the restriction will be on the phi? Instead of being 0 to pi, it will now be 0 to pi upon 4. So if you went and said, I've got this sphere interacting with this cone, you would be putting those two together. Let's see what that might look like. So you might get a question that talks about a sphere that looks like this and a cone that looks like this. And I think they'll have the word above, which makes it that guy, right? The 0 to pi upon 4 version. If they said below, it would be pi upon 4 to pi upon 2, right? Would have been the other piece. You put those together, what you get is that rho is between 0 and 4, which is what that guy's essentially telling you. Theta has got nothing happening to it, so we keep it still. And this fella gives you the phi restriction. So the bottom line is that if there's a cone, actually if it was just a cone on its own, wouldn't that be the only thing that would change, right?
Okay.
Okay, now, suppose that you get, there's always going to be a sphere, right? Because it's spherical coordinates, there's a sphere and then you're mucking about with it, right? You're cutting bits off it, you're making it intersect with a cone, you're putting it in the first octant, things like that are going to happen. So how about sphere that looks like this and that restriction? Okay, the sphere is going to generate that guy. Agreed? Now, what's an x greater than or equal to 0? You have to imagine that you're talking about a sphere being dropped down onto the xy plane. But in this world, x is going to be greater than or equal to 0. Do you see that the piece that you get is this fella? Now, how is this fella going to affect, you know, the various variables? Well, it's not going to affect phi, right? So phi is going to stay as it always is, but it is going to affect theta, isn't it? What would the restriction on theta be to generate this piece?
0 to pi.
Well, is it 0 to pi? Wouldn't 0 to pi get you that guy? And you may be saying something, Lindsay, but I can't hear it.
Negative pi over 2 to pi over 2.
Would probably be how I would describe that as well. Well, what would this one be? If x is greater than 0 means this piece, wouldn't this one be actually y greater than or equal to 0? Right? Wouldn't this be the restriction that y? Right, now if that was the question, that way I can kind of do 2 for the price of 1, wouldn't the restriction be exactly what you just said? Do you see that it affects only the thetas? What would this one give you? Sorry. Question? So this is what a y greater than or equal to 0 would do. This is what an x greater than or equal to 0 would do. Okay, what would an x less than or equal to 0 do? It would only affect theta, right? So imagine your circle and then saying, oh, you only want the piece of the circle, right? The sphere on the ground, the circle. Here. What kind of theta would that get you?
Would it just be swapped?
Okay, so what kind of values go here and here?
Be pi over 2 is less than.
Sorry, yes, I take that back. You're right.
And then negative pi over 2.
That is definitely pi upon 2. And then you're curving round this way to get to here.
Pi over 2.
Pi upon 2 to where?
3.
3
3.
pi on 2.
Yeah, that might have been what you said, but I didn't kind of catch it. I mean, 0, pi, 3/2 pi, 2 pi, right? They're like the signposts on the road. One last combination that could happen. They could tell you you've got a sphere and it works on the first octant. Now, if you're thinking about what does the first octant look like, isn't it just that corner? So what's the restriction? Because it's still a restriction on theta that does that.
Zero to pi over 2.
Oops. Now, what happens to the other things? Nothing. Rho is still what rho would be, because I don't know what the sphere is in the story, right? So it might be from 0 to 2, whatever. And phi is still going to be its untouched version. So anything to do with x bigger than, y less than, or first octant, they only affect the theta, right? They only affect the range of theta.
Can you say that one more time?
Anything to do with restrictions on x or y or the first octant, right? Those, I've forgotten how I phrased it. They affect the value of theta, right? Now, when I tell you it's the first octant, I'm really telling you 3 things. I'm telling you those 2, which is why that is here. But if it's in the first octant, aren't I also telling you that the z is greater than or equal to 0? And if the z values are greater than or equal to 0, if something's happening to the z's, doesn't that also affect the phi value? If you imagine your x, your y, and your z, if you are talking about anything above the xy plane, isn't that going to affect the range that phi takes? And phi starts up here at 0 and it finishes here and then it goes all the way down here. But if you're only doing the first octant, won't phi be affected by that? So if it's only involving the x's and the y's, theta gets affected. If it's involving the z's, phi gets affected. If it's involving all 3 of them, then both of them get affected. I think that's every permutation I can think of. Spheres and how they affect things. Spheres only affect rho. They don't affect thetas. They don't affect phi's, right? You know, x squared plus y squared plus z squared less than or equal to 9 is only going to really affect the range of rho. right? 0 to 3, typically. If you do an x greater than 0 or a y greater than 0 or something just with x's and just with y's, you're going to have an effect on the theta. And the easiest way to do it is draw a little xy and draw what part of the circle that affects. And that'll tell you the thetas that you need to make it up. And if it talks about z's, like that, it's going to affect the phi's.
So first octant does affect phi.
Say that again. What first off?
So if we're restricted to the first octant,
Yes, it does affect phi because that affects the z as well. If it's only x's, you know, x greater than 0, y greater than 0, that's a theta effect. If it's a z greater than 0, that's a phi effect. In fact, wasn't the z equal to the square root of x squared plus y squared? Wasn't that an effect on the phi?
yes.
Right. Z was involved, phi is going to be involved. If x and y is involved, theta will be involved. And if it's a sphere, rho is going to be involved. Does that feel? I hope that is kind of trying to help you get to the point where you can look at the question and figure out what the range of rho, theta, and phi is in your spherical coordinates. So that was the first one on my list. Where's my little list gone? Well, I know what's in my list if I can't find it. There we go. Yesterday I was a little bit concerned, maybe that's too strong a word, but I wasn't sure that we were up to speed on trig integration. Because in spherical, that's pretty much what you're going to integrate, isn't it, trig things? So let's give you a quick rundown on strategies for trig. If it is a single power, it could be secant cubed. It doesn't actually matter mathematically. Would you agree what you do to make that happen is the same math to make that happen, right? So I'm just going to keep things to theta, but they work equally well if you're doing them with respect to the phi. If it's a sine cubed, what's the approach? Tell me what I need to do.
I would make 1 sine squared equal to 1 minus cosine squared and have the sine theta multiplying that.
So if I'm picking up right, you would convert it into that, right?
Yes.
And after you did that, what would be the math technique to continue the process? What do you do to finish it off?
U substitution.
And the U substitution will be what?
I remember from yesterday that you used cosine squared. Would
No, I didn't.
just
Oh,
Just cosine.
Just cosine, yes. And now we're good to go. Right. So if you have a sine cubed on its own, this would be the strategy. Suppose it was sine 5. God forbid they ever do that to you, but just in case. You wouldn't change it that much. You see, all I've done is sucked out a sine, and the cos of the sine 4 becomes 1 minus cos squared squared. And it's still the U sub. What would you do if it was a cosine cubed theta on its own?
Couldn't you do the same thing?
Yes. Essentially, things just swap places. Of course, the U sub has to accommodate the change, right? What do you do if it's a sine squared on its own? Which I believe happened yesterday as well.
you do the 1/2 parentheses 1 plus sine 2 theta
Almost.
minus sine 2
Yeah.
theta,
No, not sine.
cosine 2 theta.
Yeah. These are the kind of guys you want on a piece of paper next to you, don't you?
Yeah, I always forget those.
Oh, they're so easy to forget, aren't they? There are just so many flavors and they all look the same, don't they? There's a plus, no, it's a minus, yes, it's a sine, no, it's a cosine. I mean, there are lots of places where they can switch without even thinking about it. Now, if you needed to, I certainly think you should do that. And now you can do it. Would you agree that there's a cos squared version on its own that looks almost identical to this? But for the cos squared, what's the difference to this formula?
It's a plus.
It's a plus. Right. So you now know how to do sine cubes, cosine fives, sine squared, cos squared, right? Those kind of things. How about mixing and matching now? I'm going to put them all kind of together. So this is odd with odds and odds with evens, right? In both these cases, in fact, if you've noticed in many of these cases, isn't it a U sub that gets you out of trouble? So what your decision has to be, which is the best U sub to use. In some questions, it really doesn't matter, although it'll take you a lot longer if you go one road than if you went the other. And in some circumstances, it matters a lot because it doesn't work if you pick the other one. So if they're both odd, which they are here, which one should be your most efficient U sub?
The one with the lower power.
Change that question, change that answer upside down.
The one with the higher power.
Yes. Now, as shocked as that may seem to you, won't that turn into U to the 5? Won't it eat up one of these and leave a sine square behind? And sine squared can be turned into 1 minus cos squared, which becomes 1 minus U squared. If you did it the other way, it would eventually work, but you would be adding a cosine 4 theta left over, which would have to turn into a cos squared squared, which would turn into a 1 minus sine squared squared, which would be a 1 minus U squared squared, which would then have to be FOILed out, which is a lot more work, but would work. But I phrased it quite specifically. The most efficient U sub, right? The one with the least amount of work. If I made this darn thing 15, God forbid they ever done that to you, it'd still be cosine. But this time, it would probably take you 10 minutes at most to do it. If you did sine theta, it'd take you over an hour. Yeah, horrendous looking. Okay, odd or even? Who do you pick when you got an odd or an even? Only this time, there isn't really a choice. Only one of them works.
Sine. Turn the sine power free into polar side, one square and one.
Oh, so
One
you're
big
using
one.
a technique like up here? Is that what you're thinking?
Yeah. Yes. That one.
Right, try and think it through and see what happens if you did that.
Oh, wait.
I mean, eventually it would work, but I would choose.
Oh, I see it now. Okay. So I had to
Do you know? Yeah,
Okay.
I would pick the even in this case.
Yeah.
So in this case, I'm going to go cosine theta. And the reason I would do that is that want to eat up one of these guys, and then you're just left with a sine squared, which comes into a 1 minus cos squared, and everybody's happy. So it would go quite smoothly with that one. So when you've got combinations, if they're both odd, pick the largest one as your U sub, the largest power. And if one's odd or even, typically you pick the even one, but I guess you could try the other one. It might work sometimes as well. Are we good on that? Okay, let's pretend I got a question to try and put some of these features on. Suppose you were given a sphere, x squared plus y squared plus z squared less than or equal to 9. And it also had y greater than or equal to 0. So this is region E. And you were being asked to do the triple integral. I'll find my little thing in a minute. Over E of x squared plus y squared plus z squared dv. It's a pretty standard kind of spherical coordinate question. You agree? I'm sure there's homework questions look pretty similar. Yeah, let's look at what E looks like. Would you agree that this is the bit that affects rho? And so I know that rho is going to be between 0 and 3. Y greater than or equal to 0, right? So there's no mention of Z, so I know phi doesn't get touched. So I know phi doesn't get touched. The untouched version of phi is this one. Now, what does y greater than or equal to 0 looks like? Well, isn't it the top half of the circle? And doesn't that affect theta? And starting at 0 and finishing at pi. Are we comfortable about how that became this? Just putting together what we've done today. Agreed? Right, now, this fella now becomes, oh, who cares? Theta equals 0 to theta equals pi. Phi equals 0 to phi equals pi. Rho equals 0 to rho equals 3. So that's these restrictions in. X squared plus y squared plus z squared. If you use this fella here, you would get eventually the answer, but don't we also know that x squared plus y squared plus z squared is rho squared? So that's going to be rho squared squared. Rho squared squared. Then you tag on, almost forgot, this fella, and then we're going to do a d rho, a d phi, and a d theta. And I think it tends to be, although there are exceptions to everything, doesn't it tend to be that spherical are separable? Theta is nothing with theta, so you're getting a 1d theta. There are phi here, so you're going to get sine of phi. And there's a square that's 4 plus another one, you're going to get a 6. And that question's pretty much finished, isn't it now? So that would be a kind of typical kind of spherical coordinate situation where you're trying to do a triple integral over a region that is very spherical. Are we good with this kind of generic process of how you would approach it? Any questions? Okay. So I have one last thing on my list, and that is centers of mass. So there is one example, I believe, in the homework is center of mass, so I'm going to use a version of that guy. You're given this fella, which is a cone, and they mention the word above, and you got a below, which is the sphere, and the sphere is that guy, and we're being asked to find that's, yeah, I'm trying to find something and it looks missing in the information. Oh, they want to find the center of mass. Okay. The thing that's missing is the density function. If they don't mention the density function, don't you assume then that it's just a fixed constant, K? Have you noticed that when you do a center of mass question and the center of mass is a fixed constant K, doesn't the K disappear and you still get an answer with only numbers in it? Have you noticed that? When it's a fixed rho is just equal to K, you get that? So put in a K, keep them happy. What I was about to say is, I could have just made it 1, would have made life easy. So we are trying to find first the mass, which in this case is going to be the triple integral over E of K dV. Rho squared. I want to screw up and put the sign where I should be putting a cosine. It's a sine. D rho, d phi, d theta. Okay. I've done a cone earlier today. Can you remember when it's a cone, what the restriction is?
Phi equals 0 less than or equal to phi less than or equal to pi over 4.
Agreed. So it becomes 0 to pi upon 4 as a restriction. And that's because it said the word above. If it said the word below, wouldn't I go pi upon 4 to pi? That would have been it. Okay, I got a sphere of radius 8. Doesn't that just affect the rho value? Was there anything happening here that had any effect on the range of theta? No, nothing in this question, nothing in these restrictions had anything to do with theta, right? Theta was going to be untouched. And the range for theta is 0 to 2 pi. Are you happy about the combination of these fellas and where they came from? So it is a variable separable. So I'm going to do 0 to 2 pi of 1 because there isn't any thetas. I'm going to go 0 to pi upon 4 for the sine. And I'm going to go 0, oh goodness gracious, I should have thought this one through, 8 for rho squared d rho. And I've just noticed that I haven't taken care of my K. Any particular place you want the K to go? Because as long as I only put it one place, it's fine, right?
You can just take it outside of all of them, right?
Yeah.
Oh, there's an even better idea. Let's just stick it
Yeah.
over there and forget about it. Okay, so what am I going to do? I'm going to get 2 pi Won't that be the cosine of phi evaluated from 0 to pi upon 4? And won't this one be 1/3 rho cubed evaluated from 0 to 8? Well, let's say it was pretty.
It would be the negative cosine, I think.
Okay, well caught. So 2k pi, it's basically that. Cosine of pi upon 4 is √2/2. Take away the negative of cosine 0, take away negative, you get a +1. And this horrible thing is 8 cubed over 3. I'm just going to leave it as 8 cubed over 3 right now. It's probably some ridiculous number, 512 or whatever. I guess I should do it. Shouldn't be that lazy. Wow, it is 512. So I have got 2 pi k 512 over 3, 1 take away √2/2. And that is basically the mass. I guess I could multiply these together. What's that? 1024 pi k with this fella. Now we're being asked now to find x bar, y bar, and z bar. To give you an example, to get z bar, isn't it 1 over the mass, the triple integral of x density function, dv. In this case, it's the same restrictions that we just had a minute ago. So it's 0 to 2 pi, 0 to pi upon 4, and 0 to 8. That's x, which is going to be this fella, rho sine phi cosine theta k, and then you put in the dv, which is rho squared sine phi, and I don't have room for the rest. The mass is 1 over this ugly lot, the same triple integral. If I pull that k out, it can go here and it can cancel with that k and it's gone. And what are we left with? A rho cubed, a sine squared, and a cosine. Okay, so that horrible mess is just called a bubble with dots in it now. We are going to do theta from 0 to 2 pi of 1. We're going to do 0 to pi upon 4 sine squared. And we're going to go 0 to 8 of rho cubed. Can you imagine this ugly mass times all of this? Dot, 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 dot. Z bar. Now, 0 and 0. Why can I do 0 and 0?
Is it because there is symmetry in the cone?
Yes. If you imagine a cone, let's say it's pointing downwards, and the z-axis is going right through the center of it, right? Then doesn't this shape, in the x and y direction at least, make circles, no matter where you slice it? And won't the center of a shape that looks like that have an x and a y coordinate of 0, and its z value would be, you know, somewhere up there because there's more cone at the top than there is at the bottom. If you think of that same thing, but with a sphere. Won't a sphere have a center of mass with an X and a Y also 0? So if you put the shape together, isn't there a symmetry in the X and the Y are going to be directly above the origin? So 0, 0. Won't the only thing that will affect the center of mass now is the height of the object, because that does change, right? The Z's are thicker at the top than they are at the bottom, right? In a sphere, they're thicker at the top, right? And, you know, there's less at the top than there is at the bottom. And so for that argument, I would do that. So if you're asked to find the center of mass of a spherical object, right, something using spherical coordinates, X bar and Y bar will almost always be 0 and 0. So at least you only need to find out what the horrible Z bar is. Oh, while we're at that,
Just a quick nitpicky thing there. For our Z bar, it would need to be Z times rho XYZ, right?
for Z bar, it would be Z here.
Yeah.
Yes.
Okay. And okay, then just our substitution would change. Okay.
Right. Sphere. 3D space. Horrible thing to draw. If it was just a sphere and the density function was K, I already know where X, Y, and Z bar are. I don't need to do any math. Where is the center of mass of a sphere?
The origin?
Yeah. I got a cylinder. What's the X bar and the Y bar going to be for a center, for a
0.
cylinder?
Be 0.
Now, doesn't it matter where the cylinder is?
Yeah.
Where the center of mass is? But I can tell you, you can even do that without math. See if it's 10 units above and 5 units below.
With the difference.
So can you figure out what the difference is and then half it to give you the center of mass? So the center of mass would be at 2.5, for instance. So you can, I'm not saying cheat, but you can certainly do shortcuts for very basic shapes. And it gets much messier when you start making a monster made out of a cylinder. You know, can you imagine someone did the cylinder and then stuck half a sphere on the top of it? Would an X bar and Y bar still be 0, but the Z bar would be, you'd have to calculate it, right? Could be anywhere. Okay, I think perfect timing. I'll hang about for any questions. I hope I cleared up more than I confused, and I'll see you tomorrow. Bye-bye.
Have a good day.
Bye.
Thank you, Professor.
You're welcome. We learned some cool stuff today, Lindsay, didn't we?
We did. I appreciated the review of what affected phi.
Did that clear up some fog?
That was helpful. Yeah. Thank you. See you
You're welcome.
tomorrow.
See you tomorrow. Hi, G, Jacob,
Professor,
Travis, anybody get questions?
yes, I do.
Go for it.
Can you go back to where we had the cone, where Z is equal the square root
Pi
of S?
upon that thing, pi upon 4 guy?
Yeah, so my question has to
Yes.
do with,
Okay, I'll show it on the screen.
my question has to do with the fact if the cone was below.
Yes.
So that's the part I don't get. So in my mind, I thought it would be from pi over 2 to pi, but you say it was from pi over 4 to pi. So I'm trying to understand why is
Okay.
it pi over 4 to pi.
Okay. let's try and visualize the cone,
Yeah.
the z-axis, and here this is representing the xy plane. Right. So,
Okay.
right. Now, if you're looking at a cone, and we can orientate cones differently, but imagine you were doing a cone pointing down towards the origin.
Okay.
If you had a cone, the other orientation would be a cone which is centered this way. Ah, I just drew the damn thing again. Okay, I'll keep that cone because I like it. I want to try and show you the other version of that cone.
Okay. You mean upside down or?
Yeah, pretty much.
Okay.
So,
Upside down. Yeah.
right.
Okay.
Now, in a cone, right, that looks like that, the version that you get is the top version.
That's
You can
correct.
you can put it into GeoBra and see it, right? So that's the guy that we're looking at.
Right.
Now, if I'm looking at the word above, that means, in my mind, the bigger of the two.
That's correct.
Right. So when you're looking at this shape, what we're looking at is phi equals 0 is the z-axis.
This is access. That's correct.
And if I rotate it and you rotate it in this direction here, right,
Okay.
what you're getting to psi equals pi upon 4 is essentially here. So can you imagine it's going from here
Okay.
to here.
That's correct.
Now, this fella is above the sphere.
That's fair. That's correct.
So 0 to pi upon 4 is giving you the above
The
piece.
above angle. Okay.
And
okay.
that's kind of why it's 0 to pi upon 4,
Okay.
even though it says above.
Okay. Now I was my question had to do with what if the cone was below
And
and
okay, so you would have a cone that would be orientated in a different way. So let's see what that might look like. I have a sphere here and I have a cone down here. So the sphere is big. They'd have to put the origin here then.
I see why it's from pi over 4 to pi. Okay, I see it now.
And so in this case, you'd be looking at your angle coming down a different amount
Okay.
and to see the there.
Okay.
Okay.
Okay. All right.
The good news is I don't think they have any belows. Maybe because it's just weird math and it
It's just
doesn't
weird,
end
man.
up.
Okay.
Well,
Okay.
you know, even the one I made up was ridiculously ugly. Did you, you know, these,
Right.
you don't get pretty triple integrals out of these.
Okay.
They tend to be quite messy.
Yeah.
Well, just,
Yeah.
they are.
Yeah.
Okay, what you got? Have we got
Thank you,
another
Professor.
question? Or is that us for today?
No, that was it. Thank you, Professor.
You're welcome.
See you tomorrow.
Travis, you got anything or you good to go too?
Actually, I just had one quick question.
Yes.
So y does not affect phi if you change y as a variable.
Yeah, y is, x and y are both kind of similar. They both affect the xy plane, right? Obviously. There's z up here. But if you have anything to do with x's or y's, right, things like that, then what you are basically doing is you're only affecting the circular part of the sphere when you look at its image from above. And so if I told you that x was greater than or equal to 0 and y was less than or equal to 0, interesting combination, where would I be talking about in this circle? Well, x greater than or equal to 0 is this bit, but isn't y less than or equal to 0? You put them together, wouldn't it be that little guy there?
Agreed.
And if you want to describe that little guy in terms of theta, you would be saying, well, I want to go here to here. It's probably better to use negative pi upon 2 and 0 then. And that would generate this region. What would a combination like x greater than or equal to 0, which is more typical? Well, if you're talking about positive x values, wouldn't you be talking about all of that? And what would the theta look like here? Well, here is going that way is negative pi upon 2, and curving up that way takes you to positive pi upon 2. So you would probably do your theta restriction like that. You could keep permutating these guys out. Suppose I went and said to you y was greater than or equal to 0. Right? Kind of draw this picture, right, with the circle on it, and then figure out what piece of the circle do you get when you do that. Well, would you agree that you get the top half? And then you say, okay, what would be the range of theta that would make that happen? Well, in this case, you could start at 0 and finish at pi. Right. Theta is 0, theta is pi as you curve round. But in all the combinations, if it's only x's and or y's, theta is affected. If the restriction is something to do with z's, then the phi is affected.
Okay, but phi is not affected by x or y?
Correct.
Oh, okay. I thought
Phi is more connected to what the z's are doing. And the x's and y's can do anything they like, and it doesn't affect the z's because the z's are above it, right? They're not affected directly by it. So yeah, essentially, phi is only affected by what the z's are doing, and theta is only affected by what the x's and y's are doing, and rho is only really affected by what kind of sphere you've got, right? How big or small the sphere is. So, you know, a circle radius 2 or a circle radius 10, that's going to affect the rho value.
Okay.
Right, so they all have their little niche market. Right.
Gotcha. Okay.
Okay.
Thank you
And
again.
you're welcome. Bye-bye.
Take care.